Today we are studying measuring mass and weight. Please copy down the standard benchmark indicator on a clean page in your math notebook. The student will choose an appropriate measuring device and unit of measure to solve problems involving measurement of weight and mass. Units of weight and mass. Weight is a measure of how heavy or light something is. So a rose is about 1 ounce. A man's shoe is about 1 pound, and 500 bricks weigh about a ton. Mass is the measure of a quantity of matter or stuff in an object. So, a milliliter of water weighs about 1 milligram, a dollar bill weighs about 1 gram, and a liter of milk weighs about 1 kilogram. How weight units are related. 16 ounces are in 1 pound. There are 2,000 pounds in 1 ton. For the metric system, the mass units 1,000 milligrams equal 1 gram, 1,000 grams equal 1 kilogram. So, which customary weight object will be best for measuring each object? Well, we know elephants are very heavy, so we're going to measure elephants in tons. A hot dog bun is very light, so we're going to measure that in ounces. Then a loaf of bread is much bigger than a hot dog bun and much, much smaller than an elephant, so we're going to measure that in pounds because it's in between the two. Alright, a dust particle, we're using metric mass units for 4, 5, and 6. Dust particle is very light, so we're going to weigh that in milligrams. Plastic fork is definitely heavier than dust particles, but it's not so big that we need to use kilograms, so we're going to weigh that in grams. Finally, dictionaries are quite heavy, so we're going to measure those in kilograms. Finally, for question 7, estimate the weight in pounds of 162 ounces of hot dogs. So, we know there's 16 ounces in a pound, so if we round 162 down to 160, we'll be able to do the division 160 divided by 16, which equals 10. So our answer is 10 pounds, and we always have to remember to put our label on, and pounds is abbreviated LBS. All right, ounces, pounds, and tons. The ounces, pounds, and tons are the customary units to measure weight, so they're customary or standard system. So we know 16 ounces in 1 pound, 2,000 pounds in 1 ton. So a comb weighs about 1 ounce, 4 sticks of butter weigh 1 pound, and a small car weighs about 1 ton. So to change a lesser unit, we're going from 6 tons to pounds, so we're going to multiply. There are 2,000 pounds in a ton. So 6 times 2,000 equals 12,000 pounds. For ounces, if we're going from a small unit to a greater unit, we're going to divide. So we have 1 pound equals 16 ounces. We have 48 ounces. We divide it by 16 and we get 3 pounds. Complete. Check the reasonableness of your answer. We have 4 pounds. We're going to ounces. 16 ounces is a pound, so we multiply 4 times 16. So we get 64 ounces. We have 2 tons going to pounds, so 2,000 pounds in a ton. So 2 times 2,000 is 4,000 pounds. For 3, 8,000 pounds going to tons, we divide by 2,000 and we get 4. For number 4, we have 80 ounces going to pounds, so we're going to divide by 16, and that gets us 5. For 5, we have 64 ounces going to pounds, so we're going to divide by 16. If we look back at problem 1, we know that 4 times 16 got us 64, so 64 divided by 16 will get us 4 pounds. For number 6, we know that 1 ton equals 2,000 pounds. For 7, we have 5 pounds going to ounces, and we know from question 4 that 80 divided by 16 equals 5, so 5 times 16 ounces will get us 80 ounces. Alright, for 8, we have 112 ounces going into pounds, so we're going to need to do division and figure out how many times 16 will go into 112. So we know that 80 ounces is 5 pounds. So we know we need to keep going up. So if we try 16 times 7, let's see what we get. And it equals exactly 112. So we know that 112 ounces equals 7 pounds. For 9, we have 7 tons equals how many pounds? So we're going to multiply by 2,000, which gets us 14,000 pounds. For number 10, we've got 12,000 pounds going to tons. We're going to divide by 2,000, which gets us 6. For 11, we have to describe how to change 4 pounds 7 ounces to ounces. So the first thing we're going to do is do 4 pounds times 16, which we know gets us 64 ounces. Our next step is we're going to add the 7 ounces, which will get us 71 ounces total. Grams and kilograms. The gram and the kilogram are metric units of mass. Kilo means 1,000, so 1 kilogram has 1,000 grams. A large paper clip has a mass of about 1 gram. A math book has a mass of about 1 kilogram. So if we're going to convert between the units here, a gram is less than a kilogram. So to go from kilograms to grams, we're going to multiply by 1,000. And we know the nice thing about doing that is it means we just have to move the decimal 3 places to the right. And then they had to add 2 placeholding zeros, so we get 2,900 grams. On the right, we have a kilogram is greater than a gram. So to go from a small unit to a big unit, we divide. So we're going to divide by 1,000, which means we take that invisible decimal that's behind the end of the number, and we move it 3 places to the left, and we get 67.421 kilograms. Use mental math to change to kilograms or grams. Number 1, we have 4 kilograms going to grams, so we're going to multiply by 1,000, which gets us 4,000. For number 2, we have 2,300 grams going to kilograms, so we're going to divide by 1,000. So that's going to bring that decimal place, that invisible decimal that's at the end of the number, in 3 places, and it'll go right between the 2 and the 3. And that gets us us 2.3 kilograms. For 3, we have 45,201 grams going to kilograms. So we're going to divide by 1,000, which means we're going to take the invisible decimal from the end of the number and move it in 3 places to the left to get our answer. For number 4, we have 7.8 kilograms going to grams, so we're going to multiply by 1,000, which means the decimal is moving 3 places to the right, which means we will need to add 2 placeholding zeros. So it becomes 7,800 grams. For number 5, we have 5.122 kilograms going to grams, so we multiply by 1,000, which moves our decimal 3 places to the right. For number 6, we have 0.567 kilograms going to grams. So again, we're going to multiply by 1,000, which moves our decimal 3 places to the right. For number 7, we have 9,000 grams going to kilograms. So we're going to divide by 1,000, which brings an invisible decimal in 3 places to the left. So we just end up with 9 kilograms. For number 8, we have 78,000 grams going to kilograms. So we're going to divide by 1,000 again. We're going to take that invisible decimal from the end of the number and move it 3 places to the left, which gets us 78 for our answer. We have 542 grams going to kilograms in problem 9. So we're going to divide by 1,000. So we're going to take the invisible decimal from the end of our number and move it 3 places to the left. Then for number 10, we have 50 kilograms going to grams. So we're going to multiply it by 1,000, which gets us 50,000. Please make sure you have all the work copied down and glue all of the pages in your math notebook.